Hello, welcome to our analysis on predicting NBA contracts using Bayesian Lasso regression. My name is David Shaw.
I'm Matthew Perkins.
And I'm John Williams.
First, we'll start with the motivation for our problem. So for those of you who don't know, the NBA has this thing called a salary cap. And what this does is it restricts the amount of cash that NBA general managers can allocate to their players. And we see on the right side of the screen, there's an image of how the salary cap increases over time. And so this, because of this salary cap, this leaves NBA managers in a difficult position where when they plan ahead for the future and which players are going to be on their team, they have to think about which players they're going to be able to fit under the cap and afford. So we think that in that situation, having a model that can predict NBA contracts will be highly useful to managers. So how the first part of this analysis is collecting data. And since there's no ready-made data set available to us online that includes all the features that we think go into contract negotiations, we need to collect our own data. So to do this, we're building custom-built Python web scrapers, and we're scraping from two sources. The first source is called SpotTrack, and it's where we're getting our contract data from. In total, we're collecting 2,973 contracts between the years 2013 and 2021. And this includes features like total value, average annual value, signing age, signing year, etc. The second source is player information. This is from Basketball Reference. From here, we're going to gather player statistics, so things like games played, minutes played, points per game, including the previous 3 years that a player has played, biographical information, so things like height, weight, draft year, draft overall, and awards. So at the time of signing this contract, how many NBA championships has this player won? How many All-Star games has this player been in? And in total, we have about 1,300 unique players collected and about 7,800 player seasons collected. And here's just an example of what that SpotTrack website looks like. And we see the data is in tabular form, so we're not afraid to build Python web scraper and collect that. Okay. And this is an example of what the Basketball Reference website looks like. The data is also in tabular form. And just for future reference, when we talk about model building, the statistics outlined in red are what's known as the NBA box score.
So for our model, we split it up into two parts. The first part is splitting the players up into three separate groups. So when you think about NBA players, you can kind of think of it as three separate groups, and we kind of saw that within the data. So the first group will be something like the players who are mainly just bench warmers. They don't appear in many games, and when they do, they only play a very small amount of minutes. The second group of players would be more those that we would think of as more of the role players, or maybe they come off the bench and play only about 10, 12, maybe at most like 16, 18 minutes. And then finally, the next group, the one that most people recognize, the superstars or the really significant role players, is the third group. And so we wanted to get those three groups, or those players split into those three groups, mainly because we found that the statistics in those, or for those three different groups, if we included them all together, would end up biasing each and cause the model to not be able to predict as accurately. And so we decided to predict it within the groups instead. And after we split and created group one, the remaining players who played more than 20 games, we decided which group they were in based on a Lasso logistic regression, based on what we think, or whether we think the annual contract value will be less than $10 million or greater than $10 million. And this was just, the 10 was chosen mainly through trial and error and figuring out what worked best to split the groups that seemed reasonable. The next step was creating a regression, a Lasso regression, that is, model for each of the three groups. And the reason we choose Lasso, not only for the logistic, but also for these three, is because we have so many variables, and many of them are going to be somewhat related, if not highly related. And so this helps reduce that multicollinearity aspect to allow for the model to converge. So for group one, it was found that the data response seems to be normally distributed, so we used a normal likelihood. Whereas in groups 2 and 3, it was definitely right skewed. and positive. So we used a gamma distribution for that. And we used a different kind of technique where we had used a logit over the function over the expected value to then put it between 0 and 1 to then multiply by a constant in the gamma function. So for convergence, we tested 4 different models using those, using the models we just discussed previously, or the likelihoods, I should say, that we discussed previously. So the default model is including not only the basic box score that was mentioned previously, but also the advanced statistics. So think of like player efficiency rating, usage percentage, that kind of stuff. The basic box score is the same as mentioned previously. Team indicators, what this is we basically used each team became its own categorical variable of 0, they played for them, or 1, they didn't. And that was to indicate like what team signed what player. And then finally, the last model we checked was by basic box score with interactions. So it's like the basic box score model, but this time each statistic has an interaction term with every other statistic. And one thing you'll notice that the more variables we add, the harder it is or the less great the convergence. And then one thing also is that the Gawicki statistic, they're all greater than 2, which at first seems concerning. However, when looking at the trace plots, there were really no noticeable issues. And this might just be due to the fact that it was small. We were dealing with small coefficient values for why these were larger statistics. For model comparison, because we're interested in prediction, we need to use a sort of predictive measure to accurately or to best compare the model between the models. And we decided on R squared. And it was found that the basic box score performed the best with a 0.829 R squared.
Now that we've chosen the basic box score as our model, we need to determine if it's adequate, and we use posterior predictive checks to determine that. We looked at the median, minimum, maximum statistics, and it looks like all the true values fall far to the right of their respective PPDs. Thus, their Bayesian p-values are near 0, and it really indicates that this model is not adequate and further development is needed. The biggest issue with our models was the obvious trend in the residuals. We never found a model that reduced the residuals to white noise. This is a key reason for the lack of fit, and clearly some information is missing. Also, our models predicted higher valued players. They were the outliers, and our model heavily favored good offensive players. Regarding defensive players, there wasn't much good data regarding their performance. So players who get paid for their defensive capabilities are most likely missed by the model. We discovered that it's very difficult to build a model that narrowly predicts AAV or response variable. The wide prediction intervals we got in our models would not be very beneficial to general managers. We did, however, find a few predictors that related to our response. For example, the lower the sign age, the higher the AAV, and the taller a player, the higher the AAV. For future research, we suggest looking into how to quantify subjective qualities and intangibles. Attributes like celebrity status, future potential identified by recruiters, and the value of a person as a team leader. We think these all play a role in determining AAV, but are not represented in our data. We also believe there are effects by player position that need to be explored, which could lead to a more adequate model. That concludes our final project. Thank you for your attention.